A large box contains 20 red, 30 blue, 40 green, and 10 white balls. A ball is drawn at random. Find the probability that the following color of ball is drawn. All right, first off, we've got to know how many balls are we dealing with. So if you go through and add them all up, we have 20 and 30 and 40 and 10, and that ends up adding up to 100 balls. All right, working with 100 balls here. So what's the probability of white? Well, out of the 100 balls, we know there are 10 white. Now we do need to go ahead and usually simplify our fractions. So 10 goes into itself once, 10 goes into 100 10 times, so we get 1/10. Probability of being red. Well, out of the 100, there are 20 red. Again, we need to simplify. 20 goes into itself once, 20 goes into 100 5 times, giving 1/5. Next, probability of being blue. Well, out of the 100, we have 30 blue. To simplify this fraction, we could take a 10 out. 10 goes into 30 3 times, and 10 goes into 100 10 times. Probability of being green. All right. Well, out of the 100, we have 40 green. Again, we need to simplify. We can take, we can go ahead and start. Let's do a 10 because that would give us 4/10. But then notice we'd still have a 2 in common. So if you simplify, sometimes you have to go again just to make sure it's as reduced as possible. Taking a 2 out, we would get a simplified fraction of 2/5. All right, what about getting a probability of red or green? So in this case, because it's an or, we've got to add the possibilities together. There are 20 red and 40 green. 20 and 40 make 60. So the probability we're looking for is out of 100, 60 would qualify for red or green. Simplifying, we could take a 10, but we can go bigger. We can take a 20. 20 goes into 63. 20 goes into 105 times, giving us 3/5. What is the probability of blue or white? Well, we have 30 blue and 10 white. That makes 40. So blue or white, we have 40 that qualify out of 100. Let's see, I think the biggest we could take out there is a 20, so that leaves 2/5. If you have questions on simplifying the fractions, reach out, let me know. Next up, what's the probability of getting pink? Well, out of the 100, and so we would also just could say that the probability of getting pink is 0. It's not going to happen. There's no pink balls in our box that we are working with. Looking at another kind of definition, vocabulary word for us to work with, we're going to look at complementary events. So complement of an event is the probability that the event does not happen. All right, the way we denote it is here where we have like an E with a bar on top of it. That means we're looking for its complement. The way we find a complement is it's 1 minus the likelihood, the probability of the event actually happening. So to find the probability of it not happening, we're going to take 1 minus the probability that it does happen. Let's consider rolling a 6-sided die. Find the probability of not rolling a 3. So what we're going to do here is we're actually going to go find the probability of rolling a 3. So what's the probability of rolling a 3? Well, out of a normal 6-sided die, how many of those are 3s? 1. So 1/6 is the probability of rolling a 3. Probability of not rolling a 3. What we could do is 1 minus the probability of rolling a 3. So this would be 1 minus the probability of rolling a 3 we said was 1/6. All right, in order to subtract, we would have to have common denominator. So we'd multiply by 6's. That would really turn into 6/6, which is 1. And then simplifying, we would get 5/6. All right. Now we could also still look at it as of if we're not getting a 6, I'm sorry, not getting a 3, then out of the 6 possibilities, there's 5 that are not 3s. But kind of just wanted to introduce an idea of working with a complement here. I have another example to work with that. Example 6, the answers on a multiple choice test are A, B, C, and D. What's the probability you guess the incorrect answer? So we have already looked in this case, the probability of correct in a previous video is 1 of the 4 is correct. So then the probability of not correct is going to be 1 minus the probability of correct, because it's either correct or not correct. There's no in between here. All right, so that's 1 minus the probability of correct is 1/4. If we were to turn the 1 into a fraction, 4 over 4 minus 1/4, the probability of not correct is 3/4, because 3 of the 4 letters are not correct. We're also going to consider independent events. Events A and B are independent events. They're independent events if the probability of event B occurring is the same whether or not event A happens. So B happening has no bearing whatsoever on what happened in A. Okay, they're separate events. Example, rolling a die and tossing a coin. What you get on the die has no influence or impact on what you're going to get when you flip that coin. They're two separate events. All right. Example 7, suppose we flip a coin and roll a die. All right, let's see. List the sample space. All right, sample space gets a little big here, but we're going to go through and do that, all right? So let's go through, what if we flip a coin and we got a head? Well, what possibilities? We could have a head with a 1 on the die, head with a 2, head with a 3, head with a 4, head with a 5, head with a 6. And so those are all the possibilities for head and then rolling a die. Or we could get a tail and have tail with a 1 on the die, tail with a 2 on the die, tail with 3 on the die, tail 4, tail 5, or tail 6. So that was kind of listing all the possibilities for coin toss, followed by rolling a die. What's the probability that we toss a tail and roll a 3? So basically we want to know, what's the probability of tail 3? Well, out of our possibilities, there's 1 that qualifies, but how many did we have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1 of the 12 has tails, then a 3. Continuing with this idea, we can find the probability for 2 independent events, A and B, occurring by the formula. The probability of A and B is the probability of A times the probability of B. So in other words, instead of having to do my full sample space for the tails and the 3s, I can do it like this. The probability of tail and a 3 is the probability of a tail times the probability of getting a 3. So on our coin toss, how many possibilities are there? 2. Only 1 of those is a tail. Times, if we roll a normal 6-sided die, there are 6 possibilities, but only 1 of those 6 is a 3. And then the way we multiply fractions is straight across. So in the numerator, 1 times 1 is 1. And in the denominator, 2 times 6 is 12, giving us the 1/12. But this way, we did not have to go in and create the full sample space. We could just take the probability of a tail, times the probability of rolling a 3 on a normal 6-sided die. Continue with this idea, example 8, suppose you have 8 pairs of pants and 12 shirts. 3 of the pants are black and 4 of the shirts are blue. If you walk in your closet and randomly choose a pair of pants and a shirt, what's the probability that the pants are black? So black pants and blue shirt. All right, so the probability of black pants and blue shirt. All right, so because it's an and statement, I'm going to be able to take the probability of black pants times the probability of blue shirts, because these are independent. What we pick is no influence or bearing on the other one happening. So I'm going to turn this into the probability of black pants times the probability of a blue shirt. All right, well, let's look at our pants. What do we know about our pants? We know that 3 of the pants are black. I don't know what the other colors are, but this problem doesn't have anything to do with the other colors, so I'm not really worried about that. But I do know 3 of the pants are black. But how many pants do we have? We have 8 pairs of pants. All right, so that would mean of my 8 pants, 3 are black. So 3/8 is the probability for getting a pair of black pants. Looking next at my shirts, 4 of the shirts are blue, but there are 12 shirts in my drawer in my closet that we're looking at. And so 4 of the 12 are blue. Fraction times a fraction, we multiply across. So in the numerators, 3 times 4 is 12. In the denominators, 8 times 12 is 96. We do have to simplify whenever possible. In this case, 12 will go into itself 1 time. 12 goes into 96 8 times. And the likelihood of getting a black pants with blue shirt is 1/8 based on our given information.